Appreciate it. So I believe I am now sharing. So first of all, I want to give a thanks to Jimmy for inviting me to speak. It's a pleasure. I was also scrolling through the invite list while Jimmy was chatting and saw a few familiar names. So hello, guys. Good to talk with you virtually. So I'm going to cover a few things. First, what is data-centric ML? Why should you care about it? And what Voxel 51 is doing to make your life easier in that area. And quick about me, I'm Brian, co-founder and CTO of Voxel 51. We are a venture-backed startup company offering data-centric ML tooling, both open source and commercial. My background, did a PhD in computer science from Michigan, and basically we built, as Voxel 51, the tools that we needed to get computer vision models into production. And so I'll tell you a bit more about those tools that we built back when we were trying to develop models. But basically, we determined that there's a huge need for tooling like this and decided that the best way for us to make a big impact in the space is to make those tools available as our product for you. So very important disclaimer before we get started, and that is that everything that I'm about to show you is totally free and open source. So if you feel so inclined, check us out on GitHub. I will post the link in chat, and hopefully over the course of the chat, where's my, forget about the link. You can see it right here, github/voxel51/51. If you like what I'm showing, do check it out. We'd love the support there. So without any further ado, what is data-centric ML? So this is the idea that, fast forward 7 or 8 years ago, you're working on a visual task, you've got some image and video data. Back then, data sets were pretty small, and you could probably get by with just looking at the data yourself, catching any errors. Maybe you're opening up the images in your file explorer on your machine. Fast forward to today, data sets have gotten much bigger. Here's a video data set with a few thousand samples, but these days folks are working with data sets of 100,000, a million, 10 million samples. And the problem is basically that you don't have the time or the ability to manually find the errors in your data. And the interesting thing about that is that the biggest challenge that you have in getting a computer vision model into production is not really the model architecture these days. There's plenty of architectures that you can sort of pull off the shelf. There's great tools to help you train them. But the weakness or the challenge you're going to have is how do you improve the quality of your data set? Because that's going to be the biggest issue that you have that's preventing you from getting that model ready for production. You can kind of get off the shelf and get to 80% accuracy relatively easily. But in our experience, both academically and also commercially, getting from 80 to 90 to 99% is where the rubber meets the road. And that data quality piece is going to be the place where you find yourself spending a vast majority of that time. So why do you care about data quality in the first place? Well, it can lead to huge issues on the back end of the system, right? So maybe you're familiar with issues with bias, as an example. You train a model to tag images automatically. You're Google, you publish it. It's Google Photos, everything's great, except when you start finding weaknesses where users are uploading real data that's much different than what the model saw. And you wind up with, for example, biased predictions or ethical issues and things that just aren't going to work for a product that you're releasing to the world. Of course, everyone knows about autonomous vehicles. Very bullish on that, super exciting. However, if you're not training those models to handle the edge cases that happen in real life, well, you're going to have issues, and that could lead to even physical danger to people interacting with these computer vision models. Now, on a more technical level, data quality issues, they can have a huge impact on model performance, right? So as an example, we took the data set open images from Google. We ran it through FiftyOne, our tool, and found a pretty surprising result. And that is that about 30% of the annotations, or the 30% of model predictions from a state-of-the-art off-the-shelf model trained on that data set, they actually weren't issues with the model at all. It was actually issues with the underlying data quality. And so when you have a model trained on poor quality data, you can have a meaningful decrease in the performance of that model for the simple fact that the data that you were feeding it was not good in the first place. This is the old adage, garbage in, garbage out. So this issue of how do we improve the quality of our data sets, it should be front and center for anyone who's trying to get a model into production. So what are we doing about this problem to help you? So we built this tool, FiftyOne. It's an open source tool, like I mentioned, completely free to use for individuals. Find it on GitHub. It's a data-centric ML platform. And what does that mean? Well, it means that we're providing you a way to easily load in your visual data. That means images, that means videos, that means ground truth annotations you have, that means model predictions that you have. Get it all loaded into one common format, give you a clean language to visualize it, a web application here to help you visualize, to query the data sets, to organize them, to integrate with the other best practices in your toolkit, the way that you get your data annotated, the way that you train your models, the way that you deploy your models, whether it's Kubeflow and elsewhere. We integrate into that sort of best practices toolkit that you have, with a focus on helping you visualize data, make it queryable, and then take action to address these issues that you're finding with your data sets, right? So how can you identify incorrect annotations on your data set? How can you identify what new samples you should be adding to your data set to address those issues with your models that you're finding? And a dozen more workflows, again, all around the idea that you need a tool that integrates well with the other tools that you have in your tool belt. So just in a bit more detail there, right, there's data-centric tools and there's model-centric tools, broad strokes. Data-centric tools include things like annotation tools, right? The way that you get your data annotated. On the model side, there's a suite of tools, right? You have ML frameworks, you have TensorFlow, you have PyTorch, you have the way that you're training your models. Maybe you're using an AutoML solution, maybe you're using something more like a platform to help train models, but at the end of the day, there's some way that the model's getting trained. Then you have the way that you track your experiments, right? Are you running hyperparameter searches? Are you recording the differences between the model's performance and so on and so forth, right? And then even beyond that, we have production. But what's missing is a way to sort of bring the data that you have together with the models into a one common place so you can analyze and iterate on data sets. And that's what FiftyOne does, helping you integrate with the way that you get data annotated, the way you train your models, and really make decisions based on the current performance of the model, the current data set, with that goal of getting to higher performance models through better data. So in a bit more detail about how the FiftyOne solution fits in, right? So FiftyOne is really designed to be like a one source of truth for data. So we've already covered how it is intended to help you visualize data, analyze your model predictions, but just in a bit more detail how that would look. So suppose you have data coming in, this means raw media, that's going to hit your data lake, or if you're an individual, it's just going to be stored locally on your machine or your virtual machine. That raw media, that stays where you store it in the way that you store it. What FiftyOne can provide is basically a common format to store all the metadata you have about those media. Annotations, model predictions, camera parameters, any arbitrary metadata you have. The FiftyOne data model is very flexible and is designed to help store all that information. Like I mentioned before, it then has hooks to integrate with annotations, so you could quickly export some data, get the annotations done, pull it back into FiftyOne, visualize those annotations. You can export into common formats like TF records or custom formats so that you can train your models. Once you've trained a model, or once you're in the process of training a model, definitely pull those model predictions back into FiftyOne so you can analyze them, you can compare model runs, you can make decisions about what samples your model performs poorly on versus well, and so on and so forth. Again, with the emphasis that FiftyOne can be that place where you can do that analysis. And then you have deployment, obviously, right? So once you get a model into production, it's not the end of the road. You need to pull data about that model's performance over time back into a place where you can analyze it. FiftyOne can be that place where you can track the performance of the model over time and make sure you're avoiding model drift and some of these common problems. So the FiftyOne project is designed to focus on all types of visual data today. So you'll see support for images, for video, 3D support coming soon, all the common task types you might have when you're working in computer vision, classification, detection, segmentation problems, key points, polylines, whatever format data you have, FiftyOne has a way to represent that data, make it visualizable and queryable, which we'll get into a bit later. Another unique element of FiftyOne is that it's much more than just a way to visualize data. It's really a super powerful API, right? So with the FiftyOne package, install it through Python. It's giving you a way to query the data. Here's an example of what that might look like, where you're chaining together some operations. Say, give me the samples I've tagged as validation. Let me do a filter to show only images with certain properties, slice and dice, filter search, really complex things like, hey, show me the small objects in my data set. in pixels or in relative coordinates, right? Just to give you a taste. The FiftyOne language is designed to be really flexible and give you a way to ask the questions that you care about of your data sets and pull out those specific samples of interest. Because as we know, when you've got a million samples, you can't just scroll through all of them to find that needle in the haystack. You need a way to get to it faster. And that's what FiftyOne is providing. I've already mentioned that the core library is open source. I've already mentioned that we really like to prioritize playing well with friends, whether that means integrating with other tools, especially open source tools like, say, CVAT on the annotation side, PyTorch, TensorFlow on the model training side, experiment tracking tools like MLflow and so on. Those other best practices you have in your toolkit, you'll find documentation on our website about how we integrate with those tools. And maybe we'll even show some of that in a bit later. So how do we actually go about helping you find issues in your data sets, whether that's annotation mistakes, samples that you could use some more representation of in your data set? Well, one of the ways we do that is through a part of the tool called the brain. So the brain has some automatic workflows leveraging things like embeddings, other algorithms to sort of automatically identify or run certain workflows on your data sets. I'm actually going to demo that a bit later. But to give you a sense of the kind of things it could do, it could help you find failure modes of your models, samples where the model's performing, the model is the least confident about the predictions it's making, samples that you should consider adding to your data set because the model's not performing well, and we have these visually similar ones in our data lake. Annotation mistakes. So, the input data is not always perfect. We touched on that with the open images data set. So automatic ways to help you find those mistakes. And then, like I was mentioning, workflows involving embeddings to help you visualize your data in different ways, which I'll show in a sec. All right, so the second is now. Let's do a live demo. So like I mentioned, FiftyOne is an open source project. Here you're seeing the GitHub repo. If you're interested, you'll find install instructions, pretty simple, just install it through pip. Documentation's available at 51.ai. I've got that pulled up here. The documentation's got as much info as you could possibly want and more about all the different common workflows of the tool. Check out the user guide, get an overview of the basic concepts. Definitely check out the tutorials so you can learn more about how you might evaluate object detections, evaluate classifiers, use embeddings, annotate your data, so on and so forth. A lot of information there for you to check out later. But let's do a quick hello world with the tool itself. So I've imported the library. Let me get a hold of a data set. So FiftyOne has a data set zoo in it. It has a bunch of common data sets here. This is probably the way that most people discover the tool. Maybe they want to use the Cocoa data set. We provide support to load it in one line of code, like you see here, as well as common or helpful utilities to, for example, load only a subset of the data set without downloading the whole thing, or maybe only loading specific classes like cats and dogs if you're not interested in all 80 classes in the data set, right? So you'll find helpful utilities like that for a bunch of common data sets. By the way, if you are checking out one of these data sets yourself, maybe you're trying to download the Cocoa data set directly from the source, why trust us? Well, we've partnered with the Cocoa team as an example, so they've recommended that you should use FiftyOne to get a hold of the data too. Okay, so let's load a small data set. Quick start data set. So what has happened here is the data set got downloaded, the images and the media down to my local machine. Then I loaded it into a FiftyOne data set. So I can print the data set. I can see a summary of its contents. You're seeing a few things here. You're seeing the type of data set it is, in this case, an image data set. You're seeing the number of samples in the data set, whether it's persistent or not. So quick comment on what's actually happening here, right? So data set's the core concept in the FiftyOne world. It's a container for the information that you have. Let me print the first sample just so I could talk about it. So a FiftyOne data set is composed of samples. Samples have a number of fields, basic things like the ID and the media type, and then the path to the media, right? So FiftyOne doesn't create copies of your media or really have any opinion about how you should store it. You just provide us pointers to that media together with the metadata, right? So what I did here was omitted the metadata, but you see here that this data set has a few fields. It's got some ground truth annotations. It has some model predictions. It has this floating point thing called uniqueness. So when you print a sample from the data set, you see all that information there, right? So here you see all the object detections, their bounding boxes, their labels, custom attributes like the confidence of a model prediction, and so on and so forth. So FiftyOne is providing this a way to store this data. Now let's get right to the cool part. So let's launch the app so we can visualize this data set. So again, this is using our open source tool. So this is similar to like a TensorBoard experience. This is a local web server running where I'm visualizing the data all on my machine, right? So because my data set had ground truth predictions, ground truth annotations, model predictions, those are available here in the app to visualize. The app's giving you a way to selectively filter and show specific things of interest. So here I'm showing only the ground truth annotations. Maybe I'd like to consider searching. So maybe I can see the carrots in my data set as an example. I can click into the samples. I can do cool things like zooming into the specific content, can kind of pan around. I have a nice tool tip so I can see more information about these labels. Again, FiftyOne's data model is very flexible. So if you have not only the information that this is a carrot, but that it has certain attributes, in this case, its area and whether it was annotated as a crowd, you can add those custom attributes and have access to them through the application here. Yeah, so the sidebar here is showing some ways that you can filter. There's also this concept at the top. This is called the view bar, which gives you more ways to filter. So maybe I want to limit to just 10 samples. Maybe I want to shuffle their order. The view bar is giving you another way to perform those operations. But one of the cool things about FiftyOne is that it's very interactive, right? So going back to the carrot example, here I'm looking at the carrots in my data set, but maybe I want to do something with those through code. Well, when I launched the app, I got this session object, and that object's kind of cool. It gives you access to what you're looking at in the app right now. So for example, I'm looking at 9 samples that have carrots. And so when I grab session.view, I'm seeing those 9 samples and I'm seeing the filter that I wrote to get to those samples. Or maybe I'm doing some workflow like checking for errors. So, maybe I see some problems here. I've got a mix of annotations around groups of carrots versus individual carrots. There's something fishy going on here. I could select that sample, get a hold of its ID interactively through code. Or maybe I want to tag an issue that I found. Well, I can do that through the app as well. Here I've selected that sample. I can tag it needs work. Now I've thrown a tag on that sample. So later, if I'm working with the data set at large, I can review these issues that I've found here. I could also tag an individual label and say that this particular label has an issue as well. But again, because FiftyOne's very flexible, I can also get a hold of that information through code. So I've added this sample. Over here, I could run a method called match tags to get a hold of a view that contains that one sample that has that tag. Or maybe I want to programmatically interact with that and say, you know what, I don't want to have that tag anymore. I'm done with it. I've updated the data set. I can untag it in that way. When I refresh the app here, no more tag. So some of the ways you can interact with your data here. Now, when it comes to spatial things like object detections, you could also jump into a different view. You could, for example, look at a view that contains what we call a patches view. So one sample per individual object, right? So this is the one object in that scene. Here's the other one, right? So that kind of capability is available in the tool. Now, how do you get your own data into the tool, right? So I kind of showed you a data set that I loaded through our zoo, but what would it look like to get your own data into FiftyOne? Well, really easy to do. Come to the user guide here. We can look at loading data sets. So maybe you work with one of the many common formatted data sets out there in the world, right? Maybe you work with data stored in Cocoa format. The Cocoa data set itself is in this format, but many people have adopted this as a standard format to share data. Even beyond just Cocoa data. So if you've got data that's stored in this format, well, no problem. FiftyOne has a built-in importer to get that data into it easily. Just one line of code here. Here I'm saying, hey, I've got some Cocoa data at this location. Please load it into FiftyOne. Maybe I've got some custom data, which is in no common format. It's just my own format. Well, that's super easy to handle too. FiftyOne's Python API is very powerful. Here's an example of saying, hey, I've got a new sample, this image, and then I'm going to flexibly define the information that I have about that sample. I've got a ground truth field. It contains a classification label. This is what it would look like to sort of create those samples. Then you could create a data set in FiftyOne and throw those samples onto that data set. Lots of common built-in patterns for maybe creating a data set from a directory of images, a pattern of images. Like I mentioned before, FiftyOne supports videos in the same way that it supports images. Quick example of that. Let's see. Load zoo data set. So here I'm pulling in a demo video data set. So when you're working with a video data set, the grid here sort of lets you view information about that particular sample. You can do all kinds of operations. We could scrub through the data, zoom in to view specific things, right? So the tool works quite well with videos as well as images. But yeah, loading data in that format is quite easy as well. If you have a data set and then later you want to add some model predictions, well, that's super easy as well. If you have model predictions stored in standard formats, there's probably a utility built right in to load it with one line of code. If you need to add data to an existing data set, you can already tell perhaps that with the FiftyOne API being as flexible as it is, it's quite simple to maybe iterate over a data set, write some code like for sample in data set. New field equals hello. I can write some code like this to populate new data on my data set. Now, so far we've seen that FiftyOne is pretty flexible. It's easy to get data into it. It's easy to use the app to sort of visualize that data. What about some of the fancier things I was teasing earlier? What can we find any patterns in our data set? Can we identify any issues and so forth? Well, let's get started on that by looking back at the quick start data set. So I mentioned the brain, a part of the tool. Here's some documentation about that. Here's where we have some built-in methods for working with embeddings and maybe considering as a specific case of that, working with visual similarity, right? So in this case, what I could do, I've ran this before, but I'll just show you the idea. I can import the brain. And then I could use this method called compute similarity. This method allows me to say, hey, I would like to use the images in the default case in this data set, or maybe the object patches in a specific field of the data set. And I want to generate an index against those samples or labels so that I can do searches like finding visually similar examples, right? So in the simplest case, you just run something like this. It would index the data set against the images in the data set, which then gives you the ability to use a feature in the app here. So maybe I'm gonna turn off some of this stuff. So find an image, maybe a couple images. I could use this visual similarity search to find visually similar images in the data set, right? Pretty nifty. I didn't, when I ran this, I didn't show anything about how the similarity was happening. So if you just use the default syntax, it's going to load a deep learning model sort of off the shelf and use it to generate embeddings for the samples. If you have your own model or some particular reason to believe that you have a good way to generate embeddings for your data set, well, you can provide those as well. This method has an optional argument called embeddings. You can compute your own embeddings and just pass them into the model, and then those will be used to serve this search here. But in any case, you can see that it's performing interesting results here. Based on the images I was searching, it was kind of showing images with similar color and so forth. But depending on the model you're using, it can also do other things. So here, let me clear my selection and search based on this bear here, see what it returns. You can see that it's also sort of picking out semantic similarity, right? Images in my data set that contain similar objects. So how would this be useful? Well, suppose you've worked with a data set, you've trained a model on it. Maybe you've identified a particular sample where your model has many mistakes. And maybe what you want to do is search for visually similar images that are in your data lake that you haven't added to your training data set yet. This would be a convenient way to, for example, pull up the 50 most so maybe what I want to do here is say, hey, I searched by similarity against this bear here. Let me take the 50 most visually similar ones. That's these here. Maybe I want to tag them. Maybe I want to export them and add them to my training data set. You can see how it's quite flexible in that way. Now, I should have prefaced this by saying that obviously working with FiftyOne in an interactive Python shell is a sort of a common pattern. Another great way to work is in Jupyter notebooks, which were actually mentioned earlier. So let me just give you a sense for how that might look. So here I'm going to relaunch my notebook. So here's a Jupyter notebook where I can just run FiftyOne code like I normally would, working in these cells, right? So I'm going to show some more sort of cool ways to work with embeddings. So this particular cell, you can see what it's doing. It's loading a data set. It's pulling out a particular split of that data set. This data set has tags. So when I match on the test tag, I'm pulling out the test split. Now what it's doing here is taking the images in this data set and it's computing, it's using the full image, like all of the pixels as an embedding, and then saying, hey, let's use another brain method called compute visualization, because I'm interested in visualizing this data set as a scatter plot like this, which we'll get to in a second. So anyways, I ran that offline. So now let me just load up the data set real quick. See, I loaded the data set, I printed it. It's got 70,000 samples. It's got some ground truth annotations. Let me pull out the test split. That's 10,000 samples. I previously ran this block up here where I've got this thing called MNIST test, which is the results of my embeddings computation. So let me just load those real quick. Now, when you're working in a Jupyter notebook and you launch the FiftyOne app, well, the app by default will actually just appear in the output of your cell, which is kind of nifty, right? So now I'm working with the FiftyOne app, but I'm doing it in a notebook. And one of the cool things about this is that you can obviously explore in the same way that you can in your web browser, or as with the app as a dedicated window in your web browser, like we were looking at earlier. Closed it. However, when you're working in a notebook, you also have this freeze command, which will actually take a screenshot of what you were doing in the app and embed that screenshot into that notebook, so that if you load it later, you can see sort of the outcome that you got to when you were working with the data set, and sort of treat it like a record, a scientific record of your experiments, if you will. Okay, so I've got the data set, I've got these handwritten digits. I generated this visualization. You see it says 2D here. So let me just plot that real quick and show you. So what I asked it to do was generate a scatter plot of the two-dimensional visualization of that data set that I computed. And I was used the ground truth labels on this data set, right? This data set has a ground truth field. It has these labels, which are obviously the digit that you're seeing. And what I told FiftyOne to do is color those points according to their ground truth label. So here we have an interactive plot. So if I want to, you see here, this blue cluster is mostly 0 digits, right? So I can interact with this plot, can select those digits and see those corresponding digits up here. But I can do much more. So for example, you see this clustering. I have some points of wrong or different colors in this cluster here. So let's turn off the 0 cluster and let's take a look at these. So these are points. Every point represents an image. And if I highlight those, what those are digits in the data set which are labeled as 0. Sorry. Excuse me, they are labeled as different things, but they're very visually similar to zeros. So you can see that these are sort of like problem cases or potentially challenging points because they look visually similar. You know, here we have something which is a 6, but it's very visually similar to 0. So these are sort of like points that can be easily confused or might be difficult for the model. So kind of an interesting finding there. Also a good way to find actual annotation mistakes. So this is a very standardized data set. There aren't many mistakes in it. However, in a case like this, these are basically samples which are likely to be actually annotation mistakes because they are definitely visually similar to all these 0 digits, right? So common pattern or common useful pattern to check as a way to find where you might have mistakes in your data set, as opposed to scrolling through thousands and thousands yourself and sort of trying to figure it out. Okay, but how can we level up this workflow to the next level? Well, this data set has, it has 70,000 samples, 10,000 of which are in a test split, 60,000 of which are in a train split. Well, maybe I have a typical case might be that my test split is unlabeled, right? So in this particular case, I have labels for the test split. But suppose I didn't have labels, how might I automatically generate labels for the test split based on what I have in the train split, which is labeled? Well, one interesting way to do that using the idea of embeddings might be to generate a new visualization where now I'm doing it against the whole data set. So let me just load that real quick. Oh, and by the way, let me freeze my, so when I run this freeze command, what has happened is the this app that used to be interactive is now replaced with an image. And so if I were to export this notebook, load it up later, I'd see where I got to with my findings here, which is kind of neat. But okay, let's do a new experiment. So I generated a visualization, which I've now loaded for every sample in the data set. Now, what I want to do in this case is pretend that I don't have labels for one of the splits. So I've generated a list where it'll either say unlabeled for samples whose label I want to guess, or if it's in the train split, it'll have labels already. So let me launch a new app instance. And let's visualize these as well. So all of these red points, those are the ones that we're pretending are unlabeled. And then all these other clusters are the points that do have labels. So obviously when you turn on these new points, well, they kind of fit in the clusters that existed, right? And that's not by accident. What this is saying is that the samples that correspond to these red points here, they're really visually similar to all these points here, which are labeled as 0. So how can I act on that? Well, let me show only the unlabeled points. Let me grab these guys here. These are the ones that are in that 0 cluster. So I'm loading them in the app. Yep, sure enough, these are all zeros. So maybe I want to use the tagging feature to say, hey, this is predicted 0. Add those tags to the data set. Boom, we've just generated 5,976 candidate labels for all these digits here. Good way to sort of automatically or semi-automatically annotate data sets. All right, but let's show a more realistic example. So let me, in this case, combine the concepts we were looking at earlier of using model embeddings together with these visualization capabilities. So here we'll work with the Berkeley Deep Drive data set, a little bit more sophisticated data set. And then we will generate some embeddings, computer visualization. I already did that. So load the data set real quick, 10,000 samples. Load the results that I generated. All right, let's look at this data set. So this data set's got a bit more content in it. It has a variety of different types. You know, it's got some samples, for example, that are marked as having rain. You can check those out there. But let's generate this visualization here. So again, what had happened is that we took a model. So we provide a model zoo similar to how we provide a dataset zoo, which has a bunch of models that you could use to generate embeddings off the shelf. You could also just compute your own embeddings. And we fed those embeddings that we computed into our visualizer. So now we're looking at the results and we're coloring by some of the other information we have. This data set has time of day labels. So we're coloring the points by the time of day, but the clusters are coming from the visual characteristics of the images. So two big clusters, there's a nighttime cluster and a daytime cluster. That's pretty interesting. But what's more interesting are a few things. Number one, what are these outliers, right? So we can grab these points and see what those are. Well, these are actually samples where the dash cam of the vehicle is in the way, right? They're very visually similar to each other. Or what about these points? These are points that have rain on the dash, right? Kind of interesting points. But then what about these points? So let me turn off these two. You can see that there's kind of two clusters. There's a cluster of daytime and a cluster of nighttime. Okay, makes sense. Our model kind of knows about images that came from daytime versus nighttime. But what about these points here? These are points that were labeled as night according to the data set. And again, this is just the ground truth annotations coming from this data set, which is quite standard. But these points are suspicious. They're in the wrong cluster from all the other nighttime points. So let's look at these here. So these are points that were labeled as night, but obviously you can see they're not night. These are basically annotation mistakes, right? So one of the cool ways that you could find and potentially act on needs re-annotation mistakes in your data set. Since I got to an interesting place in my experiment, I'll go ahead and freeze so that this becomes now, so this becomes a screenshot. So now I've sort of captured a finding in my data set. I was working with this data set. I used this sort of interactive workflow in my Jupyter notebook. I encountered some issues. I found some samples that are mislabeled. I tagged them. Maybe I want to take action on them by pulling up the Python API and working with that data. Maybe I want to send it for re-annotation and so forth. Interesting finding thanks to getting hands-on with your data. All right, so apologies, I forget how much time I had, so I better probably wrap up. So again, quick reminder that everything that I was showing here is totally open source and free to use. So if you liked what you saw, go ahead, check out that GitHub repo. If you're feeling generous, give us a star. For anybody out there who's wondering how they can get involved, well, do that star thing. Check us out on Slack. We've got a Slack community that you can find from the website, from the docs, pretty much everywhere. Hop in there, have a conversation with another user, with one of the developers of the tool, ask your questions. We'd love to hear from users. Like I mentioned before, I recognize some names actually in the chat. So hello again, see you in Slack soon. A couple of resources you can check out. We've got some blog posts about FiftyOne. We have an installation guide. I've mentioned the documentation in the tutorials already. Do check those out. A lot of resources to help you get up to speed with FiftyOne. And then if you're wondering how we make money, well, that's because we sell a version of FiftyOne called Teams. So Teams is a version of FiftyOne which is designed for organizations that want to use FiftyOne as the one source of truth for their data. So it's not just a localhost TensorBoard kind of style. It's actually a proper SaaS deployment of FiftyOne with a centralized database. With it, you can have multiple workflows using Python in parallel to load in data. You can visualize your data sets through the web portal without even using Python. So it's more suitable for non-technical workflows, QA, and so forth and so on. So if any of that sounds interesting, do reach out and be happy to talk about it. All right. Thank you.